Happy day, students. So in our last class we were talking about superposition of simple harmonic motions. To start from there only, there is one more case that I wanted to discuss with you. It's something like this, in which y1 is given 3 sin of omega t plus 30 and y2 is minus 4 cos omega t plus 30. And as you know that when we are adding it, when we are doing y equal to y1 plus y2, in that one both need to be in sign form and it should be in addition form. Minus should not be there. So how to convert it? We want to convert this alone. So this y2 I am writing as 4 sin omega t plus 30 plus 270. So this is 270 plus theta. Sin of 270 plus theta is minus cos theta. So that means the same. Okay. So y2 is what then? It is 4 sin of omega t plus 310 degrees. And y1 is 3 sin omega t plus 30. Now in this case, which one is A1 and which one is A2? I always told you that A1 means who is having less phase. So less phase means this one. So this is A1 for you. So let us add and find out what is the final answer for this one. I am removing it here because now y2 is this. Okay. So now final y we know is we will be writing as sin of omega t plus theta. Okay. Now what is A value? Before that, to find out A value, we have to find what is the phase difference between the two. What is the phase difference? You can see that phase difference is 270. So if we add it, A equal to the root over 3 square plus 4 square plus 2 into 3 into 4 into cos 270. Okay, cos 270. Cos 270 is 0. Cos 270 is 0. So this entire factor is gone. So this becomes 3 square plus 4 square, 9 plus 16, 25. Square root of 25 is 5. Okay. Now what? Now we want to find what is this? Theta value. Check what we have to do for that. So first I am making this 3 sin omega t plus 30. So if this is horizontal, I know that this is making 30 degrees horizontal. So A1 is here. This 30. A2, what angle it is making? 300. 300 from where? From here. So like this 300. So it will be, this is actually 270 here. This is 270. So it's 300 is somewhere here. That's A2. Okay, and between A1 and A2, what is the angle? Now this one is 270. So this is 90. Okay, where will be the resultant? Resultant will be somewhere here. So we have to find it what it is. Let us use the formula to find it. Tan theta equal to A2 sin phi. Now what is A2? 4. 4 sin phi. Phi was 270 by A2, by A1, 3 only, plus 4 cos 270. Okay, now sin 270 means what? Minus 1. So minus 4. And cos 270 here 0. So what is remaining? 3. So minus 4 by 3. So tan theta is coming minus 4 by 3. That is minus 53. Now this minus 53 is from where? From x. This is minus 50. But you have to write from where? You have to write from A1. So from A1, how much is the angle? 53 plus 30. So how to write final answer? Final answer we will be writing as y equal to 5 sin omega t minus 83. Why minus? Because it's below. It's below. If it's in the front side, you would have written positive. But here it is below. So how I am writing? I am writing 30 plus 53. That means 83 degrees. But it's below, so minus 83. Is that okay? So this way we will be adding the simple harmonic motions. Now let's come back to the interference. In interference, we have to add simple harmonic motions due to two waves, and we also know that interference are of two types: destructive interference and constructive interference. Okay. Now, constructive interference means is the point where you are going to get the maximum amplitude or maximum intensity. Okay, and maximum intensity or maximum amplitude, it basically depends on cos phi value. Now, when cos phi is maximum, or what is the value of cos phi when we are talking about it as maximum? It is 1. That means phi should be 0, 2 pi, 4 pi, 6 pi, or I should say 2 pi n for constructive interference. For destructive interference on the other side, that means minimum value of intensity, minimum value of amplitude. For that, what should be cos phi value? Cos phi value should be -1. Then phi value should be what? Phi value should be pi. Okay, then 3 pi, then 5 pi, then 7 pi. That means we can write this as 2n plus 1 pi. And this one also n is 0, 1, 2, like that. Here also n can be 0, 1, 2, like that. Okay. This is destructive and constructive interference. We know about them already. But when we talk about wave optics, in wave optics, this phi is mainly dependent on path difference. What the path difference is, let's see. It's mainly a function of path difference. That means if this is source S1 here, this is source S2, and suppose the point is here, from S2 the wave is going, let's say it's traveling x2, and from S1 it's traveling x1. Okay, so you can see that if this function I write as y equal to a1 sine omega t plus k. Okay, and if you want to give initial phase also, you can give x1. Here, this is y1, this is y2, and this is a2 sine omega t plus kx plus phi. Okay, but when we are going to write over here, the disturbance because of this one gives this simple harmonic motion like y1 equal to a1 sine omega t plus kx1 plus phi1, and this one y2 equal to a2 sine omega t plus kx2 plus phi. Okay, now if I am going to find the phase difference between the two, the delta phi, you can see that omega is same, that if we are talking about coherent sources, right? So what is the phase difference now? This is the phase, so we will be writing it as k x2 minus x1 plus phi2 minus phi1. Okay, but when we are talking about wave optics and interference in wave optics, normally the questions will not be asked in which initial phases will be given to you. So most of the questions will be based on this as the phase difference. I am not saying that this will not come, maybe asked, but the probability is very less. So we will focus on this one right now. Okay, so I am saying that let's say phi1 equal to phi2, so then delta phi equal to k delta x, which you can write as 2 pi by lambda into delta x, as we know that this k is propagation constant, whose value is 2 pi by lambda. Okay, so now when we have found that the phase difference is due to the path difference in this case, then the condition of constructive and destructive interference we can write in terms of path difference also. Again, constructive interference we found as delta phi equal to 2n phi. The condition for constructive interference was delta phi equal to 2n phi. And from here, we are getting delta phi is actually what? 2 pi by lambda into delta x. So here we are putting 2 pi by lambda into delta x equal to 2n pi. This 2 pi gets cancelled, delta x is coming and lambda. So that means the path difference for getting the maximum intensity should be whole number multiple of lambda. Whole number multiple of lambda. If delta x is 0, in that case also we are going to get maximum intensity. If delta x is equal to lambda, then also we are going to get maximum intensity. If it is 2 lambda also we are going to get maximum intensity. Let's see for destructive interference then. For destructive interference, we know that the path difference delta phi we wrote as 2n plus 1 into phi. Okay, and if I am going to put this delta phi as k delta x, which is 2 pi by lambda into delta x, then we are going to get over here delta x is lambda by 2 into 2n plus 1, and in this one n is 0, 1, 2, all that. So if you put 0 over here, you will be getting path differences lambda by 2. If you put 1 into this one, you are getting 3 lambda by 2. If you put 2, you are getting 5 lambda by 2. That means for getting the destructive interference, the path difference should be odd number multiple of lambda by 2. Odd number multiple of lambda by 2. Okay, that is the condition. Provided there is no initial phase difference. Okay, so based on what we learned as far as constructive and destructive interference, some basic questions again we are going to solve. Okay, so let us see. Now suppose here the question is, there are two sources, S1 and S2, and suppose that the distance between them is 3 lambda. Now the question is, how many maximum intensities are possible? Okay, between them. How many maximum intensities are possible between them? Okay, now first thing is, if we start solving it, go for the solution. The first question arises is, what is the maximum path difference between the two at any position, at any given position? Anywhere you take the point, where will be the maximum path difference and where will be the zero path difference? Okay, so let's talk about zero path difference first. Where is zero path difference? Now suppose I take one point in the middle, exactly in the middle, I say that that's O. Okay, so the wave which is starting from S1 and goes to O, how much is traveling? 1.5 lambda. From S2, how much the wave is traveling to reach us? 1.5 lambda. So x2 minus x1 is 0. x2 minus x1 is 0. So here the path difference is going to be 0. Okay. Now, where is the maximum path difference? Maximum path difference will be, if I say at this point, that's S1. At S1, the wave starting from S1 travels how much distance? 0. But from S2, how much it will travel? 3 lambda. So maximum path difference at any point you take, at infinity also, maximum path difference will be 3 lambda only, it cannot be more than that. That means on the line joining the two sources, it will be maximum path difference. Okay, and how much will that be? 3 lambda. Is that clear? So here is zero path difference. So when zero path difference is there, one maximum intensity I am going to get. Right. So now let's start from here then. At this point, what I am going to get? Because of S2, how much path is being traveled by the wave? 3 lambda. Because of S1, what path is traveled by the wave? 0. 3 lambda minus 0. So path difference is 3 lambda. So that means here I am going to get third maximum. Why third maximum? Because delta x is equal to n lambda I have studied. And if this is 3 lambda, then what is n value? N value is 3. So this is third maximum. Okay. Here is central maximum. This is called 0th maximum. Because here path difference is 0. So this is 0, this is third. Is there here middle 1 and 2 also? Yes, definitely. Because here path difference is 3 lambda. Here path difference is 0. So definitely somewhere there will be path difference of 1 lambda also. Then there will be path difference of 2 lambda also. Are you able to understand? So here will be 3 lambda path difference between S1 and S2. Somewhere here will be 2 lambda. Somewhere here will be lambda. and here is 0. Okay, let's see on the right side now. If I talk about this point, how much is the distance traveled by wave starting from S2 to reach here? 0. But from S1, 3 lambda. So that means here again third max is there, because here path difference is 3 lambda. So same way 2 lambda also will be there somewhere, 1 lambda also will be there. So how many maximas are there? 1, 2, 3, 4, 5, 6, 7. Okay, 7 maximas are there. Same way if I ask you how many minimas are there, then for minimas what we require the path differences? Lambda by 2, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2. So here path difference is 0. So here some point will be there where path difference will become lambda by 2. Here will be 3 lambda by 2 for sure, and here will be 5 lambda by 2. Why 5 lambda by 2? Because it's less than 3 lambda. 3 lambda is here. So 5 by 2 will come here. Same way on this side also. 3 lambda by 2, 3 lambda by 2, and 5 lambda by 2. So how many minimas are there? 1, 2, 3, 4, 5, 6. So 6 minima. Minima means destructive interference. Minimum intensity means minimum. Okay? And maxima, how many are there? 7. Did you understand? Okay, let's solve one more then. One more question, similar type. Suppose now I am giving the distance between S1 and S2 is 4.5 lambda. Okay, question is how many maximas are there? How many maximum intensities and how many minimum intensities are there? How many minimum intensities? Okay, first thing what do you do? Search for the center, where there is 0 as max. Here how much is the path difference if I take this point? Say 4.5 lambda. 4.5 lambda, that means there should be maximum or minima here? Minimum. Okay, this will be minima. Which minima? Fourth minima. Which minima? Fourth minima. How can I say? This 4.5 lambda. And for minima, we know that delta x is 2n plus 1 lambda by 2. So what shall I get? N. So that I can get 4.5 lambda or 9 lambda by 2? 4. So what is here? This is fourth minima. Fine. So here path difference is 4.5 lambda. So somewhere here will be 4 lambda also. Then there will be 3 lambda also. Then there will be 2 lambda also. And there will be lambda also. Okay. So 1, 2, 3, 4 maxima here. And this one is fixed. Why? Because this is 0. So 1, 2, 3, 4, 5. Same way this side also will be there. Exactly same this side also. Lambda, 2 lambda, 3 lambda, 4 lambda. So how many maximas are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Its answer is 9. What about minima? Minima, this is 1 minima, 4.5 lambda. This is 3.5 lambda. This is 2.5 lambda. This is 1.5 lambda. This is 0.5 lambda. Again here 0.5 lambda, 1.5 lambda, 2.5, 3.5 and 4.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many minimas are there? 10 minimas are there. Are you able to understand? So this way we can find out how many maximas are there possible in this case and how many minimas are possible. Okay, let's see for a few more questions. If there are two sources, S1 and S2, okay, and the difference between them, let's say 3.2 lambda. Okay, and this is the central point where we know that maximum intensity is there. Suppose there is a listener which we want to move in this direction. So find how much he should move so that he can get next maximum. Okay, how much minimum he should move to get a maximum intensity. He is already at maximum. Okay, from here how much he should move so that he can get maximum intensity. Okay, now first of all, which intensity is this that we have to find? Shall I say this is first? Because here path difference is 0. Here will be 3.2 lambda. So path difference is actually increasing when you are going like that. So first maximum intensity will come when the path difference is how much? Lambda. So suppose now this distance is x. So how much is this moving? How much is S1p? S1p I will say is 1.6 lambda plus x. Why? Because this is 1.6 lambda. And how much S2? 1.6 lambda minus x. What is path difference? S1p minus S2p. And how much this should be for getting maxima over here? It should be equal to lambda. Why lambda? Because here is 0, next become lambda only. So what is S1p minus S2p? 1.6 plus lambda minus 1.6 lambda plus x. So when you are solving it will come 2x. What will come? 2x will come. 2x equal to lambda. So that means x is equal to lambda by 2. So if you move here lambda by 2, we are going to get first maximum intensity. Okay? Or he is going to find the next maximum intensity. Okay? Same way, let's do one more. Suppose that two sources are here, S1 and S2. This is 4.6 lambda. Okay, this is center. Now suppose that the listener is here and he wants to move in this direction with speed v. So we have to find when he is going to find second minima from this position. Second minima from this position. So see then, what is the path difference between this and this point? If suppose at this point you are there, you know that S1's wave will travel 0 distance, whereas S1's wave will travel 0 distance, whereas S2 will travel 4.6 lambda. Okay, at 4.5 lambda we are going to get the first maximum. We know it. When the path difference is 4.5 lambda, we are going to get the first maximum. Okay, when the path difference is going to become 3.5 lambda, in that case we are going to get second minimum. So the first minimum we are searching, suppose, then we will say that this is x. Then how much will be this? 4.5 lambda. This is x, then this will become 4.6 lambda minus. Okay, so if we are saying that this is point P, then path difference will be what? S2P minus S1. So that we can write 4.6 lambda minus x. S1P is minus x. But what is delta x? Because we are searching here first minima. Here path difference is 4.6 lambda. So here how much will be the path difference? 4.5 lambda. So here is 4.5 lambda. Bring it over here, this one is coming minus 0.1 lambda equal to minus 2x. Minus is gone. X value is 0.1 by 2 lambda or 0.05 lambda. This much you have to grab. If suppose you are going for the second minima here, so here path difference will be 3.5 lambda. Third 2.5 lambda. Fourth 1.5 lambda. Further 0.5 lambda. So depending on what the position is, where you are, you will be putting up this value. Okay? Is that clear? So suppose one more thing in this one itself I will say. Suppose from here we want to go for the third minimum. This already we got first, this is second, and this is third. So first one when you found out here, then the path difference was 4.5 lambda. For the second one, 3.5. And and the third one 2.5. Okay, so suppose it's here, and let's decide this value is y. So we'll write S2p minus S1p equal to 2.5 lambda. Okay, what is S2p? Again, I will be writing same way, 4.6 lambda minus y. And what is S1p? Y itself equal to 2.5 lambda. So minus 2y equal to 2.5 lambda minus 4.6 lambda will become 2.1 lambda. Okay, minus is getting cancelled. Y is equal to 2.1 by 2 lambda, that is 1.05 lambda. Okay, so this way we can find out how many maximas and minimas are possible when the two sources are in one line. Okay, and the listener is walking between them. Alright, that's it for now.